Hey guys, I wanted to finish off the last two parts of problem number 5. However, I made a mistake in part F, which led to a mistake in part G, which would definitely throw us off for H and I. So I wanted to correct myself. C ended up equaling 3, positive 3, which changes our roots in part G, which would mean that I would take x squared plus 3x plus 4, setting it equal to 0. The quadratic formula would give us the following, which is going to make a difference. Okay, so this negative sign right there is what will make the difference. That is what our complex roots for f of x would end up equaling. So now we can move on to part F. It says draw the 4 roots on the complex plane. So our 4 roots were x equals negative 4, x equals positive 2, and x equals negative 3 over 2 plus or minus I root 7 over 2. So on an Argand diagram, what that would look like is, whoops, I got that line cockeyed there. There we go. All right, right here, since there is no imaginary component on either of those, these first 2 real roots will simply be on the real axis. Okay, so this would be, let's call this x sub 1, x sub 2, and then x sub 3 and 4. So here would be x sub 1, which would be, oops, I'm sorry, this would be x sub 2, this would be x sub 1, and then somewhere over here I would have x sub 3, let's go with this one, which would equal negative 3 over 2 plus I root 7 over 2. So you can see the imaginary component is positive, and then symmetrically speaking, this would be x of 4, which would be negative 3 over 2. Again, the horizontal travel minus I root 7 over 2. So there you have them on the Argand diagram. Okay, now it says in part I to express each of the 4 of the roots in the form r e to the I theta. So if I had x equals negative 4, that would be 4 cis pi, which would be equivalent to 4e to the I pi. Okay, likewise, if x equals 2, that would be 2 cis 0, which would be 2e to the I times 0. We would probably leave it in that form. For the other 2 roots, I've got x equals negative 3 halves plus or minus, this gets a little bit more complicated, I root 7 over 2, which is kind of weird, but what you can think of this as is theta is equal to, theta being the angle, right? If I were to look back up here, Apple Pencil, dead. I've got this angle theta where the tangent of that angle will be negative, and then down here, likewise theta, but the tangent of that angle will be negative or negative, which would be positive. So theta equals arctan of plus or minus, now stay with me here, root 7 over 3. All right, so now what we have r e to the I theta. I know what my theta values are. All that I need to now know is what r equals. Once I know what r equals, I can put both of these values into that r e to the I theta form. So I'm going to sketch negative 3 over 2, root 7 over 2, and what I know will be true is both of these modulus will be the same length, right? Because of the similarity, actually congruence of these 2 triangles, those 2 hypotenuse will be the same. So here I know theta, and here I know theta, so we'll call that theta Let's call that theta 3 because that goes with x sub 3, and theta 4, which goes with x sub 4. Okay, so let's use the Pythagorean theorem to then solve for each of these, and then we'll have both in r e to the I form. Okay, so let's do a little Pythagorean work. So x squared plus, actually I'm gonna get fancy here. Let's go real portion of x squared plus imaginary portion of x squared is equal to r squared. Okay, so the real portion we said was negative 3/2. The imaginary portion was negative root 7/2. Okay, and r will be the square root of all that good stuff. So if I square that, I get 9/4. I square this, I get 7/4. This is going to be really awesome because I get 16/4, which is 4, so r equals 2. So it looks like x sub 3 and x sub 4, if I put them into r e to the I theta form, will end up being, x sub 3 will end up being 2e to the I, okay, hang with me here for a second. This angle is pi, so this angle will be, this angle will be pi minus theta 3. So that'll be pi minus arctan of negative root 7 over 3. Okay, and then x of 4, very similarly, I'm trying to be deliberate here, will be pi plus arctan of root 7 over 3. Okay, because I would go pi plus an additional. Okay, and notice the negative, the positive, depending on what quadrant it falls in. It's a 6-mark question. It's pretty loaded, but I think it's somewhat doable. If you can find the modulus or the hypotenuse, and you can find this form here, you're probably giving yourself a good 2 marks in addition to these simple 2 marks. And then it's just getting it in this form that will get you your final 2 marks. All right, guys, complex numbers are complex for a reason. Let me know if you got some questions. We can talk it through. Have a good one.